Okay, so this is for my fourth year. So this is a little introduction to the periodic table, and it is going to be the beginning of how do we do some formulas from names. So what are the things that you have to know? Well, the things that go down your periodic table, change the color of my pen. These guys here, we call them groups. So in my head, groups are like gravity and they fall down. So the groups are what goes down. Scientists call the rows that go across, we call them periods. And the reason they're called periods have to do with the fact that the properties of each row, they repeat periodically. So as you go down from row to row, you'll see similar properties. So that's where the word period comes from, because of the repeating properties. Okay, we then have something whereby we give certain groups names. So if you live in group 1, and we will do this in a few weeks' time, we call these the alkali metals. So this means if you put these metals with water, you will make something that has a pH greater than 7 with water. Group 2, over here, we call the alkaline earth metals. And they do a similar thing. If you react them with water, they need a little bit more energy in which to do it. But again, with water, they will give you a solution that has a pH greater than 7 in water. We name this block in the middle. So these guys here, these guys are called the transition metals. And we'll talk about what this means in a second, but these guys are used as catalysts in the chemical industry, and these guys have variable valency, so that gives them very special characteristics. They're usually very coloured, but they have lots of uses as catalyst. We then have to go all the way over to here, where we have this particular group, which is called group 7, and we call it the halogens. So things like chlorine, fluorine, bromine, iodine in this. And our final group over here, this last one at the end, here, these guys are called the noble gases. On our periodic table that you can see here, they're called group 0. They can be called group 8. And some periodic tables have decided to give these ones numbers. So you'll see on some periodic tables that these will all have numbers all the way over 17, and finally this one up here, group 18, but we use the old school way of doing it. So you will hear me refer to group 1, group 2, that is on the very left hand side of your periodic table, and then you will hear me refer to group 7, which are our halogens, and group 8, which are our noble gases. Just a little bit about hydrogen. So in some periodic tables, hydrogen will be put over here on the top of group 1. And the reason for that is because everything that is in this layer over here in group 1, they have 1 electron in their outer shell. So that's why hydrogen is put there, just because it fits that group. But in reality, hydrogen is a non-metal and should be on, would be where our stepped line is. So we've already talked about the stepped line in lesson. The job of your stepped line is to separate your metals from your non-metals. Okay, things that live around the step lines have properties of both metals and non-metals, but everything over on this side are going to be metals, and everything that's over on this side is going to be non-metals. So we had this word valency already. I'm going to scoot down, and we're going to put in very quickly another one. Click done. Okay, we talked about valency. So valency is the number of electrons that an atom has to lose or gain to get a full outer shell. So number of electrons to lose or gain for this outer shell. So if you reside in group 1, we put a +1 charge over this, because for group 1, it keeps flicking, doesn't it? For group 1, if we are losing an electron, your protons will be greater than your electrons. So however many electrons you lose, that's going to be your charge. So in this case, it's easier to lose 1 than to try and gain 7. So our group 1 get a +1 charge. Similarly, our group 2 get a +2 charge. And again, they've lost 2 electrons. So in group 1, you have 1 proton, you have 1 proton more than what you have for your electrons. And similarly, in group 2, it's going to be the same thing. So that's why these are positively charged. We go over here to our group 3, and we can say that these have 3 valence electrons. So, and again, the positive charge is coming because there's going to be 3 more protons than there is electrons for any of the elements in group 3, and similarly for group 4. In reality, in group 4, we only really deal with carbon. And we'll talk a little bit more about that when we do redox in form 5. So these are the charges over here that we give when our protons are greater than our electrons. When we go to the other side, so our noble gases, these over here, they're going to have no charge. They are inert, they don't like to react, they don't need to react because they all have full outer energy levels. So they are very, very happy being as they are. Here in fluorine, so if you just have a look at fluorine, our information on fluorine is this. So what are these numbers telling us? A little reminder, this is my atomic number. This tells me my number of protons is the definition. And the bonus piece of information it gives us is the number of electrons, because all atoms are electrically neutral. This number up here is going to be our mass number, and this tells me the number of protons and the number of neutrons. So you know in lesson I had introduced you to ape man, so you can work this out whatever way you want, but I use ape man to do it. So if we have to know proton, neutrons, electrons, and an electron configuration, then for fluorine I have 9 protons, I have 9 electrons, because atomic number is equal to number of protons, which is equal to number of electrons. And to work out my neutrons, I take my mass number of 19. So mass number, take away atomic number, gives me my number of neutrons, which is 10 neutrons. Going back to my 9 electrons, my 9 electrons will be arranged in a 2-7 electron configuration. And you can see that here. Here's the 2. And to get to fluorine, I have to get to 7. So fluorine and all of the halogens have 7 electrons in their outer shell. It's much easier for them to gain 1 electron than it is for them to lose 7. So for group 7 then, now we're going to have our protons will be less than our electrons. So we will have negative numbers. So seeing as fluorine gains 1 electron, it's going to have a -1. Oxygen is going to be -2. It has to gain 2 for a full outer shell, and nitrogen in group 5 has to gain -3. It's really important that you know these numbers, because when we start naming, trying to write formulas from names, then this becomes very, very, very important. So I'm going to scoot this one up here. The last day in lesson we talked about cations and anions, and I gave you quality diagrams of our little cat, and he's got his little positive eyes and his little positive mouth, and he's got his little fat belly and his bushy tail. And then we have antions, but anions. So this is our little ant, and he has all little negative symbols in him. He's kind of got little negative symbols on his feet. So cations are positive ions, and anions are negative So essentially our positive ions here are group 1, group 2, group 3, group 4. And over here these guys will be group 5, group 6, group 7. Now we talked about how we do our naming of things. So if we take something like, we will go with magnesium chloride. So what are the rules? So the first thing that we're going to say is that this comes from the metal side, and we're going to say that this is a non-metal, and together magnesium chloride is what you call an ionic compound. And ionic compounds, we also refer to them as salts. So you may be aware of sodium chloride is the table salt that we put on our chips, dinners, whatever it is you wish to put it on. So the rule for the metal when we are naming metal salts is the metal name stays the same. It does not change. So you just have to recognize that this is a metal and a non-metal by looking at my periodic table. So this guy is going to be on the left-hand side of my periodic table. This guy is going to be on my right-hand side. That is a metal and a non-metal. So the name of the metal stays the same, but the name of the non-metal, we change the last part, changes to an IDE. So chloride was originally, the non-metal it came from was chlorine. And you just need to be aware of the different ones that we've done, that we've given you. So we had H minus as a hydride, and obviously that's coming from hydrogen. We have nitrogen, so it's kind of a contraction in the name, will be N3 minus because it's a group 5. So this becomes a nitride. We have phosphorus. So see, can you do it in your head? So again, a P3 minus, this becomes a phosphide. We have oxygen is, I think, an easy one. O2 minus is going to be an oxide for oxygen. Sulfur, S2 minus, sulfide, that's fairly easy. Fluorine, fluoride, so they're all relatively, sorry, this should be a 1 minus. Easy. And bromine and iodine. So we get a bromide and we get an iodide. Okay, so these are all the non-metal sides. And we can just, we're changing the name, but we can get their charge by looking at their position on the periodic table. Okay, so usually from formulas, it's pretty easy to write names from formulas. So if I tell you CaNO, this is my metal. The name doesn't change, but you need to learn what the symbol is. So this is calcium. This is my non-metal. This is going to change the end of its name. So it's obviously oxygen when it's just O, but now we're going to change it to oxide. And then to name it, we just put both things together, calcium oxide. So usually name from formula is pretty good. Now we are going to try and write formulas from names. So how do we do that? Write formula from names. So we have an example, iron 3 sulfide. Now we've already talked about the fact that iron here is a transition metal. They have variable valency, and it's this number in the brackets tells you what the charge is. So this is going to be an Fe3 plus. That is its charge. We know the sulfur, if we look at our periodic table, sulfur is in group 6. So if it's in group 6, it has an S2 minus. And what we're trying to do is we're trying to write a formula. So we use these crossover arrows, they're called. And what we are taking to do our crossover, or what we're moving, is just the number. We're not interested in the charge. So here, when we do this, I'm taking down a 2 and I'm taking down a 3. And these numbers, I'm just going to combine them now as a formula. So the 2 is going to be what's called a subscript. So it's kind of down below the Fe. Similarly with the 3, it's going to be down below. Now what's really important when you're doing your naming is the compounds will be electrically neutral. There will be no charge overall on these. And this is how you work out, have I done it right? So here I have 2 by a 3 plus. Here I have 3 by a 2 minus. So 2 by 3 is going to be 6 positives here. 3 by 2 is going to be 6 negatives here. And if I add 6 plus and 6 minus together, I get 0. And that gives me confidence now that this formula is correct. Okay, going to do another one for you. So at the moment, these are all what are called, we're using simple ions. So we're going to try here, magnesium oxide. So I need my periodic table open. Obviously, this is my metal. This is my non-metal. We know that this is originally oxygen. So we know from looking at it that magnesium lives in group 2. So now it's going to get a 2 plus charge. And we know oxygen lives in group 6. It's going to get an O and a 2 minus charge. We are going to do our drop down arrows like so. And again, the number that we are taking is this number that's in front. And I'm bringing this number 2 to the right hand side. And I'm taking this number 2 over here to the left hand side. And now we get this formula, Mg2O2. Now there's a thing in chemistry where we have things are in proportion of, they have to be simple whole numbers. So because these 2 go into each other, we actually write it as an MgO. So in chemistry, 1, this is technically 1 and 1, but we never show the ones, it's always just inferred. So these guys can divide into each other by 2, and we write it as a O and an O. And if we just look at the charges, I have 2 by 2 plus. I technically have 2 by 2 minus. This 2 by 2 plus is 4 pluses. This 2 by 2 minus is 4 minuses. When I add these together, I will get my total of 0. So that makes this correct. So we are going to try a different one. Let's see what we will do. So I know you know what the formula for this is, but we'll just prove it. So we're going to go with sodium chloride. So I know this is my metal. I know that the charge on it is going to be +1 because it lives in group 1. I know this is my non-metal. And I know that we are going to, this came from chlorine. So its charge must be -1. We write it as Na plus, Cl minus. We're doing our drop down. So this is the time when 1 is here, but it's not written, it's just inferred. So I have a 1:1 ratio, and I now just stick them together. NaCl is my formula. I have 1 by 1 plus, and I have 1 by 1 minus. So this is a 1 plus, this is a 1 minus overall, and these add up to 0. So that makes this correct. Now, the one thing that we haven't talked about are what are called complex ions. So these are ions that come as a package together. And I can guarantee you now, come Christmas assessments and summer assessments, I will positively get many people giving me the wrong answer. So on page 39 of our book, we have a whole load of complex ions. I'm just going to write ones here now that might be important. So I have SO4 2 minus and SO3 2 minus, and we've already done S2 minus. So you have to go and learn these. There's Quizlet flashcard sets for you. You can put them on your own flashcard sets. This is literally a learning exercise, and you have to get them into your head because it'll make life much easier if you understand what they are and how they work. So SO4 is a sulfate, SO3 is a sulfite, and we've already had S2, which is a sulfide. Okay, this is what's called a simple ion because there's only one element in it. These guys are our complex ions because they have both sulfur and oxygen. So if we were to let us pick something, and if we were to say that we have an element and it is called lithium sulfate, how do we work it out? So this is still our metal. This is our non-metal, but it's our complex ion. So there's more than one element in it. How do we write it? So we know lithium is in group 1, so it has to have a positive 1 charge. And again, the 1 isn't written in, it's just inferred. We have to know that our complex ion has SO4 2-. So we do our drop down, our cross arrows and drop down. And obviously there's a 1 here that's inferred, so we put 1 here. And we're looking at this number 2 here, not this 4. So if what I'd like for you to do is when you're thinking of this is a whole package, the charge is something separate. So it's this little number 2 that we're taking, like so, and then we see can we write. Now, sometimes this is difficult to put together, so I'm going to show you a little hint. I write my lithium because I have 2 of them, so that gets its little 2. I only have 1 sulfate, so actually I can write it like this and I will be correct. But what I'm going to ask you to do is I want you to get into the habit of literally just put a bracket around this. And once we get to a scenario where it is not a number 1 here, we'll be sorted and ready to go. Okay, I'm going to find you one whereby we will have to have multiples. So I'm going to go this time with the name of aluminium, last one, sulfite. So again, my metal doesn't change its name. It lives this one in group 3. So we write aluminium 3+. This is my non-metal, but it's a complex ion. So you have to know and learn it. So this is SO3 2-. We're going to get ready for our cross and drop down arrows, and I'm taking the 3 and the 2. So the 3 is going down here along this line, and my 2 is going along here down this line. Now, it's easy to write Li2, that is fine, but if I don't put this complex ion in a bracket, this is how it gets written, and that is not correct, because what this says here is I have 2 lithium, I have 1 S, and this reads like I have 33 oxygen, which I do not have. Okay, so this does not work. It's not the correct formula. So we still have Li2, and as I said to you earlier, once you write your SO3, you just get in the habit of writing brackets, and now I'm putting this 3 outside my brackets. So what does this tell me I have? It tells me I have 2 Li. Technically, I have 3 outside by an S, so I have 3S inside there, and I have O3 by 3, which is 9 O's in total. So that makes a little bit more sense than our 33. Okay, I'm going to leave this here now. If there's one piece of recommendation, it is to learn your simple ion names and charge, and that comes from knowing what group they're in. You can always get a periodic table, and you have to learn your complex ions, because I guarantee you, if I gave you this as a formula next Christmas or in summer, I will get lithium sulfur oxide, and you've just now lost your marks because you did not learn your complex ions. So please make sure that happens. Ask questions if you need help.